Welcome to another, what's going to be a great DevNTell. If you didn't know what DevNTell is, it's a 30-minute window for members of the DAO to showcase something they're passionate about or have been working on. This can be an awesome project you've been working on, demonstrating unit testing best practices, automation goodies, smart contracts, how to structure a project, etc. Basically, if you've got a passion for something, this is your opportunity to share it with the community. And I'm happy to pass it over to Team MerkleMe, who is going to show off their Web3 hackathon project, the MerkleMe API. Over to you, gang.
Thank you, Narb. Thanks for having us again. We're, like Narb said, we're just going to give a quick informal introduction to our Web3 hackathon project, MerkleMe. One thing that Jose was talking about before we started was he was wondering how much people knew about Merkle Trees in general. So is there anyone who has no idea what in the chat right now that has no idea what a Merkle tree is or what Merkle verification is? Don't be afraid.
I think it'd be worthwhile if you gave like a brief overview of it.
Okay, I'm gonna leave that to Jose. I'm just here to give the introduction and just give a little background. So MerkleMe, the project was me, Jose, or is me, Jose, Orlundo, and Kenny. I'm not sure if Kenny's in the chat right now. Doesn't look like it, but so Jose came to us with this idea, this really good idea to create kind of a backend API to abstract away Merkle tree verification and proof process. And we just got it organized pretty quickly, and we went straight at it for the Web3 hackathon. And we created a small prototype, very simple prototype that we're quite proud of. And yeah, so I'll give it over to Jose, and he can give the Merkle tree background.
Awesome, thanks, Vinny. So I'm gonna share my screen real quick here, and I've got a little presentation. So I'll start with that.
I guess I'll just quickly mention that Jose was kind of responsible for the original idea. Kenny and Orlundo took care of UI and front end, and I kind of did most of the back end implementation. So
awesome, thanks, Vinny. So so this is MerkleMe, and the idea behind MerkleMe is that we want to abstract away the process of using and implementing Merkle trees for different applications. The primary application that we're kind of focused on right now is just using it for whitelist. And so the idea is you generate, you publish, you verify. I want to give a quick primer on what a Merkle tree is for folks that may not understand what they are. So a Merkle tree is a hash-based data structure. It's in the form of a binary tree, and where you have at most 2 children per node. So for example, in the tree you see here, you'll start at the very bottom where you have, say, a list of 4 addresses, and each of those is hashed recursively up to the top where you get to your root hash. And so that's what a Merkle tree looks like. The cool property of Merkle trees is that because of the recursive hashing, for any given list of addresses, for example, once you get to the top, the root hash, you're pretty much guaranteed to always have the same root hash if you have using the same base set of data. So it's easy to verify the underlying data, making sure that it hasn't changed, and then you can do that without needing to see the entire set of data. And so this is used for like data verification on distributed systems. So one interesting thing to know is that GitHub uses Merkle trees for commits. I didn't know that until I did a little deep dive into Merkle trees. As far as like how you verify data, so for example, if I have a list of 4 addresses down here at the bottom, and I want to create a Merkle tree from this list of addresses, I'll get up to the root hash, and now all I need is the root hash. So for example, if I wanted to verify the second address to calculate the root hash, I wouldn't need my entire list of addresses to do that. I would need to generate a proof. And I'm going through this quickly, and I apologize if this, I just don't want to spend, you can spend hours talking about Merkle Trees, so I'm just trying to do this very quickly. So if I just wanted to verify, for example, address 2, I could do it by generating a proof. And you do that by basically hashing all of these till you get to the root hash. And I wouldn't need all 4 addresses to do that. I would just need to know the minimum pieces of information I would need to know are the address itself, the neighboring address, and then this hash here. So the way it would work is I would have this address so I can hash it. I would need this address so I can hash it, and then I can get this hash. And then with this hash and this hash, I can get the root hash. So there's an algorithm in place. We didn't do this. These are built-in libraries that we're integrating that will basically do this. It'll tell you the minimum pieces of information you need to get to the root hash. So it's an efficient way to calculate the root hash without having to know all of the underlying data. So here's an example where we're generating a proof where we want to get the proof for this address. And we're just basically getting the minimum pieces that we need, which is this and this to get to the root hash. And then what a proof is, it is an array of nodes that you can use to generate the root hash without needing to know the entire data set. So each leaf will have its own proof. All right, so that was a quick primer on that, and I'll give it a demonstration of what that looks like. But a use case for Merkle Trees is using NFT whitelist, where a project owner may want to open up their minting contract to a specific list of folks or addresses. And so right now, the implementation is fairly complicated and time consuming, and usually requires running a node backend to generate the trees and the proofs. So we want to abstract that away and make it easier. So here's a quick overview of how that works. In MerkleMe is you bring your whitelist, you upload your whitelist to MerkleMe. The API will then generate a Merkle tree for you, and then it'll publish to IPFS your whitelist, your root hash, and something else I call a tree summary. Not important right now. I need to improve the documentation, but generally the 2 pieces you need to know are your whitelist and your root hash. So MerkleMe will do that. All you do is copy and paste your whitelist, and then it will generate this for you. So once you get there, this is the generate and publish aspect of MerkleMe. Then you get to the verify aspect. And this is where we take the proof for a specific leaf, and then we generate it for that leaf. So the front end, for example, will take an address, and then we'll request a proof from the MerkleMe API, and then it'll provide that proof back. And then with this proof, you can interact with your minting contract to verify if they are indeed on the whitelist and they can mint or not. So I'm going to stop there and give a quick demonstration on sort of how this works. So if I go to, let's say I've got an NFT project and I want to create a whitelist for my project. So I'll come to MerkleMe and I'll get started. I'll just call this anything test. I can put an email in here. It's optional. If I do put an email, it'll send me the IPFS links to my whitelist and my proof. I'll just leave that out for now. I've got a little set of addresses here that I can use. These are basically the addresses you get provided to you in Remix, plus 2 of my dev wallets. So I'm just going to copy and paste that in there. Click on that. Okay, I've got my Merkle tree. So now that I've got that, it's pushed my whitelist out to IPFS. This is on Pinata. So that my whitelist is out there. I don't have to share this with anybody. Some folks may want to keep this private, and that's okay, but at least you have it available to you. And then I also have my root hash, which is saved on IPFS as well. So with this information that I've been provided, now I can go and generate a proof for any address that wants to try and mint. So for example, in this list of addresses, I want to verify this address and make sure that it's a valid. I want to generate a proof for this. And so what I'll do is in your in your front end, you'll send a post request to our API. So to mimic that, I've got this example here where I'm going to hit the API to get a proof. I'm going to provide the IPFS link to my whitelist, and then I'm going to provide the address that I want to generate a proof for. And when I do that, it'll hit the API, and it'll come back and then provide you this proof. So now that you have this proof for a specific address, then you can go and interact with your minting contract and see if this is a valid proof that they can mint. And we have a sample remix instance. This is a very simple minting contract, just as provided as an example. And so it's just called my token. And down here, we're importing. This would be pretty standard for most folks that have looked at done a minting contract. One thing you'll see different here is we're bringing in this Open Zeppelin lot utility called Merkle Proof. And what that is it's just a simple function that has 3 arguments. You give it a proof, the root hash, and then the leaf that you want to verify against. So we're bringing that into our minting contract here. And we're calling it. So for brevity, I'm not going to go into too much detail because I don't want to run out of time, but we're going to go ahead and I'm going to deploy this on Rinkeby with my address here. To deploy this, I need the root hash, so I'll just grab the root hash real quick, which I can just get here. It's on IPFS. Deploy that. Once that deploys, I'll have access to the minting function. Okay, so once I've got that, I've got the minting function here. So to mint the token, I need to provide the proof. And so I just did that here. But I'm going to do it again because I'm going to grab the whitelist address, put that into my request body here. And then the leaf is the same. So I'm going to call that again. Now I've got my proof. So I'm going to grab this and I'm going to try and mint. And it's already pulling in my address. So it's using the address that I'm providing a proof for. So I'm going to throw that in there for mint the token. Prove this. Wait for that to go through. And we should get a success. And there we go. So I'll look here. There's my proof, and I was able to mint an example ERC 721 with this address. So I know I'm kind of going through this very quickly. One of the things that potential use cases we see for this is other types of off-chain data validation. So that doesn't necessarily have to be a whitelist. We want to explore other potential use cases where you use Merkle Trees. One that I think would be really cool is for POAP whitelists. So imagine you just finished up an event, you get everybody's addresses, and you can basically generate on the fly a whitelist for those folks that were in that event so that they can go and then get those POAPs without having to rely on a public facing or a public Google sheet that we typically see right now. So there's other areas to explore as well. And then roadmap items, some things that we want to work on are improved documentation, and then do some improvements on the API. So for example, allowing users to integrate their own IPFS gateway or own accounts. So there's not just Pinata, there's other services that interact with IPFS. So it would be nice for them to be able to use their own accounts. Provide easier API access to do this programmatically without having to go to the front end and do it. And then also create additional API endpoints for custom Merkle Tree applications other than the standard whitelist. And I just did that in 10 minutes?
Nice one. That was really good, Jose. I just wanted to interject and say before Jose came to me with this, he was exploring Merkle Trees pretty in depth, and I wasn't aware of how they worked. And he kind of turned me into a Merkle Tree fanboy in the end, because the cool thing is for example, why GitHub would use it you take a hash of all the data or the set of data, and that's all you need to compare. Two people can trustlessly compare the hashes and be like, okay, we have this, we're talking about the same set of data here. And you don't need to compare line by line your code or the files, you know? So that something, one thing changes in those files, the hash completely changes. And that's what's so powerful about Merkle tree verification and Merkle tree proofs is that, especially for a decentralized web, is all you need are those hashes. And then, yeah, it's pretty, it gives a lot of power to users to compare data in a trustless manner. So that's the big takeaway I took from all this, which I really liked about Merkle trees. I know you don't have to save tons of data on chain either.
Yeah, you only have to store the root hash. I skipped over that, but basically in your minting contract, all you need is one piece of data, which is your root hash. And so, as a team, what we've talked about is that our vision is that we want to see this as a piece of the Web3 tooling that people can use for using Merkle trees without having to, mess with all the implementation and other stuff that goes along with it.
Yeah, this is fantastic, Ing. Thank you so much for sharing. Do you guys see any opportunities for us to perhaps use MerkleMe in the DAO, or is it too early yet to know concrete use cases?
Vinny, I'll let you touch on that.
To be honest, no. Like I kind of wanted to open up questions, and we're all kind of new at this. This was like I said, I didn't know about it until I learned about it while working on the project, pretty much based on Jose's initiative. So was kind of looking for feedback from the community to see, like Jose said, if there are other, I can imagine people might have in mind other use cases that we've not even thought about, other potential use cases, or maybe someone has a good criticism that we didn't think about where they say, this is useless, or this will be useless for X reason. So if anybody has any input, feedback, criticism, we'd love to hear it.
I would have a question. So I looked into Merkle proofs myself already, and so we're planning to do distribute ERC20 tokens to certain amounts for certain addresses. Is that possible with Merkle tree? So basically, instead of just one address, you would have an address and an amount.
Yeah, I mean, like we said, it's any set of data. So if you can pack in any other data in there with the address, if something changes, then you'll have a different hash, and yeah, it won't be verifiable in that sense. So totally, I can't say 100%, but sounds like a decent use case. Yeah.
Okay, so instead of just the address, you would have address plus, I don't know, amount or some combination for unit.
Exactly. You can even different, that's essentially what GitHub is doing, right? You have within a branch, you have a set of files, and anything changes within that one of those files within that branch, you're changing the hash. So yeah, what I understand definitely would work. That's a good idea.
And the files that you just showed, are they available somewhere on the internet?
MerkleMe.io.
Yeah, exactly. But the code, how to integrate it in the front end, and the contract that you showed in Remix is something.
Yeah.
Kind of
Jose on the GitHub too, right? Yeah, it's all there.
All there. Okay, great. Okay.
It's on the GitHub and on the documentation of MerkleMe.io, right?
Yes, everything we have, everything is open source. It's on our GitHub, the API and the front end. Yes.
Awesome.
Let me get those links for you.
Thank you very much. It's great, by the way.
Thanks.
Thank you.
Any other questions? I'm to be honest, I was waiting for someone to just knock our idea down and be like, this isn't going to work. I'm still waiting for someone to tell us why not a good idea.
Yeah. I see Jose. Jose wanted me to discuss the front end. Yeah, go ahead.
No, somebody was asking about some specifics about the front end, so I figured if you wanted to talk about it.
Yeah. Well, the front end was Next.js and literally vanilla CSS. That's what we use on it. 1 second, let me pull up a stream. So I did the design on it. I'm not a designer, but I just was like, me and Kenny, like, we just got on a call one day and just kind of like jammed out to like doing something on Figma. We're doing something with Figma. And yeah, we quickly put it together. Right now, it's all of these are it's kind of messy right now because we're undergoing like a different look for the front end. I got an actual designer, and we're probably gonna have a redesign. But yeah, we designed it on Figma, and then we just spun up Next.js, and then got the front end started. Honestly, it was just like nights of just like being up all night, just kind of fixing it, tweaking it as much as we could until it was where we wanted it to be. But of course, I still want it to be a little bit more pristine. So we're working on that. But if Kenny want to talk a little bit more about the front end as well, because I was more like Padawan and he was more like Master Jedi on it. So, yeah. If you want to pitch in and just talk about connecting the API and so forth, he can do that.
So the front end is built with Next.js, and we used the normal CSS and CSS module for the styling, and also for state management. I said we should go with we used stand, just a very simple state management, because we did some simple state management, transferring the data from a particular page to another page. So we used stand, a library for the state management, but we can probably in the future, we are going to change it to the just simple context API for managing the state. And for the API interaction, we interacted with the API, we consumed the API with Axios and the rest. Also for the rest, it's just a very simple front end. And if you check the code, it's something you can understand. But the everything is actually going on in the back end, which is what Jose has done and Vinny also. And also I think all of us, Jose and Vinny worked on the back end. And Orlando and I, we worked on the front end, but I would say all of us worked on the front end, because when we make a PR, there are changes to work on, and all of us, we did work on the front end, and it is a very, very great experience for most of us. Yeah, the front end is just a very simple Next.js application, which you can, when you open it, it's something you can definitely follow up, and I do not have anything to say.
Yeah, and also Peter Pan with just like Ethers or Web3. We didn't use it because I see Jose answering the question. We didn't use it because we didn't need to connect a wallet or anything like that. So most of it is just like API, back-end API work. So, the front end was pretty much very simple. It's just me designing it, and then we just go and build out the quick pages that we need to. So yeah, no need for it. I definitely thought we were going to need it as well, but then I realized, like, oh, we're not connecting any wallets. We're just, like, taking in data and sending back data, so.
Excellent. We have about 6-ish minutes left. Does anybody have any final questions for the gang?
I was just going to mention, so for Pixel devs, we were considering Merkle Trees, but then sort of went with a real-time server solution. The only problem we ran into consideration was having to continually regenerate the snapshots. But obviously a tool such as yours, I guess you could automate that a lot more easily too. If you wanted to regularly update snapshots.
Yeah, absolutely. Because all you have to do is just regenerate it, and you just need to give your contract a new root hash.
Right.
Really quick and easy.
It's a great project. Thank you.
Thank you.
We appreciate you guys, and Narb, we will now accept our winnings for Web3.
You'll know soon enough, friend. You'll know soon enough. For real, this was a really fantastic project, gang. I'm personally was nerding out over here over Merkle Trees. So thank you so much for sharing. And if there are no final questions here, I guess we can call it. Going once.
I do want to say real quick, we are looking for like people to test it out. So if you want to try it out, definitely like feel free. MerkleMe.io, I'll just put it in the chat. And then if you have any questions, just reach out to one of us. Jose is usually the best when it comes to like troubleshooting and answering the questions of like issues that may occur. But reach out to any one of us, me, Vinny, Jose, Kenny. We'll help you guys out.
Great stuff. Yeah, for sure. All right. If there are no final questions, going once, going twice, sold. All right. Thank you again, gang. Team MerkleMe. Like I said, thank you so much for sharing. So everybody stay tuned. I will be posting a link to claim POAPs for this event, and then Team MerkleMe, I will DM you separately for your special speaker POAPs. But I want to wish everybody a very happy Friday or Saturday, wherever you may be. Happy weekend. And we'll see you back here next week for another fantastic installment of DevNTell. All right, gang?
Sweet. Thanks, guys.
All right. Cheers.
Thank you.